Hello everyone, my name is Pisek or Benz. Welcome to 𝐏𝐨𝐬𝐭. This video is the third video that we will summarize a lecture series, the 2025 Agentic AI course as offered by UC Berkeley RDI Center. For the series full playlist, take a look at the description below. And also, don't forget to subscribe to our channel at 𝐏𝐨𝐬𝐭. We are on YouTube, LinkedIn, Facebook, X, and Substack, so that you get AI insight that build your foundation of AI solid. Also, I would like to disclose that this video is made with the help of AI, in particular Notebook LM, but I did my best to maintain factual accuracy. Alright, the third lecture is about post-training verifiable agents, which was delivered by Jiantao Jiao, who at the time is a director of research at Nvidia. This video is very interesting because you are going to get to see the difference between the previous LLM, which is a very good talker but prone to make mistakes, and the agentic LLM, which is supposed to be much better at planning and executing tasks accurately. The improvement is possible by setting a measurable way to verify LLM actions and reasoning, and also because we have an efficient reinforcement learning as well. Alright, now it's time for the full summary.
We're all pretty used to AIs that are really good at sounding convincing, right? But what if we could build one that's designed to be provably correct? That's what we're talking about today. We're going to dive into a builder's guide for a whole new kind of AI. These are called post-training verifiable agents. Basically, it's all about shifting the goal from just sounding right to actually being right. So let's get into it. This is a summary of a lecture titled Post-Training Verifiable Agents. Now, I know that sounds like a bit of a mouthful, but we're going to break down what that really means. And trust me, it's a huge leap forward for AI. We'll get into why this is such a big deal, and then we'll walk through step by step how you'd actually build one of these incredible systems from scratch. So here's our game plan. First, we'll cover what makes this AI so different. Then we'll get into the essential building blocks. After that, we'll tackle a really tough question. How do you measure real intelligence? Then we'll get our hands dirty with the training recipe. And finally, we'll look ahead to the future and the big challenges that are still out there. All right, let's kick things off. So what's the big idea here? Well, it all comes down to a fundamental shift in what we want from our AI. We're moving on from answers that we like to answers that we can prove are correct. It's a move from preference to proof. And this really breaks it down. On one side, you've got your traditional LLMs. Think of them as expert conversationalists. Their whole goal is to make you happy, to maximize what they call human preference. Success is all about whether the answer feels right to you. It's totally subjective. But then on the other side, you have these verifiable agents. Their mission is completely different. They're built to maximize verifiable rewards. For them, success isn't about how you feel, it's about getting the job done, getting it right, and being able to prove it. This quote really gets to the heart of it. When it talks about being environment feedback aligned, that's just a fancy way of saying the AI learns from the real world, not just from what we tell it we like. It's not about being a people pleaser. It's about what actually works. I mean, think about it. If you're asking an AI to write code, a friendly answer that's full of bugs is completely useless, right? You need something that is verifiably, provably correct. Okay, so we know what we want to build. Now, how do we do it? What are the core ingredients we need to cook up one of these agents? Turns out it really boils down to 3 key things. So, if you wanted to start building one of these today, what are the 3 things you absolutely have to have? And here's a hint. It's not just about the AI model. It's just as much about the world you put it in. And here they are. You need an environment, you need tools, and you need a verifier. I love this analogy. Think of it as the agent's workshop, its set of tools, and the quality inspector. And here's the key. You can't skimp on any of them. You need a ton of diversity across all 3 to build an agent that can handle the real world. So let's start with the environment. This is the agent's entire world. It's digital workspace. It's all the info and context it has to play with. So if the agent's job is fixing a software bug, the environment is the entire codebase. If its job is to research something, the environment is a web browser. It's the whole sandbox. Next up, the tools. If the environment is the workshop, then the tools are the agent's hands and feet. They're how it actually interacts with and changes that environment. We're talking about things like APIs that let it run code, query a database, or even just perform a Google search. This is how it gets things done. And last, but honestly, maybe the most important piece of the puzzle, the verifier. This is the referee, the ultimate impartial judge of success. It's the thing that checks, did the agent actually succeed? For code, that's a unit test that passes. For a math problem, it's a program that confirms the answer. You absolutely cannot build a powerful agent without a high-quality verifier, because that's what provides the ground truth. It's the North Star for all the agent's learning. All right, we've got our ingredients, we have a plan to build this thing, but that brings us to a really, really tricky question. How do we know if it's actually smart? How do we define what it means for it to work out in the wild, and not just in the clean, controlled lab where we trained it?
Yeah, this is the million-dollar question, right? We've got all the parts, but how do we know if we've built a genius or just a really good student who's great at acing the specific tests we gave it? We need to make sure it's not just a one-trick pony that has memorized the answers. We're talking about the problem of generalization, and that means we need to think way bigger about how we measure success.
So what does real intelligence look like in an agent? Well, it's a few things. It can handle a bunch of different tools, not just the 2 or 3 it was trained on. It can deal with vague instructions. When you ask a person for something and don't spell it out perfectly, it needs to be able to do that. It has to be robust, so it doesn't just crash if an API changes a tiny bit. And maybe most importantly, it has to be able to fix its own mistakes, to debug and handle weird errors when things go wrong, just like a human expert. This is such a powerful idea. Think about it. When we design the tests, the benchmarks for these AIs, we're doing more than just grading them. We are literally defining what we, as a society, consider intelligence to be. That's a huge responsibility. So we have to make sure our tests are actually holistic and good measures of what we value.
So what makes a good test? 3 things. First, it's got to be hard. Is it challenging enough to actually mean something? Second, separability. A good test should be able to clearly separate the A students from the C students, the really powerful models from the weaker ones. And finally, diversity. It needs to cover a huge range of tasks, so the AI can't just game the system by memorizing a couple of tricks.
Okay, we know what we're building, we know how we're going to grade it, now it's time for the main event. Let's talk about the actual training recipe. And it's basically a 2-step process that beautifully combines learning by watching with learning by doing. First up is stage 1, supervised fine-tuning, or SFT. The easiest way to think about this is like learning from a textbook. You're showing the AI examples of correct answers and having it imitate them. It's a great way to get a solid foundation. But if you only do this, the AI becomes rigid. It can't think for itself. And that's where stage 2 comes in, reinforcement learning, or RL. This is where you throw the textbook out. You let the agent explore, experiment, and learn from its own trial and error. This is where the magic happens. This is what forges real flexible intelligence. Now, getting that RL stage right is tricky. It rests on 3 key pillars. The first one is to train longer. Why? Well, there's this problem called entropy collapse, which basically means the AI gets stuck in a rut and just keeps giving the same boring, safe answer. Training longer forces it to stay creative and keep exploring new ideas. The second pillar is to train harder. This is simple but brilliant. You give the AI a bigger reward for solving harder problems. This creates a really strong incentive for it to tackle the tough stuff. And finally, you have to sample better. This is all about being smart with your resources. It means finding ways to generate better, more creative attempts during training so you discover amazing solutions without needing a supercomputer the size of a city. So there you have it. That's the recipe. But, and this is a big but, we are still on the absolute frontier here. Building these agents is nowhere near a solved problem. So let's wrap up by looking at the huge, unresolved challenges that the brightest minds in the field are wrestling with right now. And it's so important to remember this. This field is still in its infancy. It's super, super immature. There is no single right algorithm that everyone agrees on. It's kind of like the Wild West of AI research right now. Everyone is exploring and trying to figure out the best path forward. And that leads to some absolutely massive open questions. For example, how on earth do we build enough diverse, interesting environments or digital worlds for these agents to learn in? How do we teach an AI to have common sense, to prioritize what's important like a person does? We still don't know the perfect balance between that imitation phase and the exploration phase. And maybe the deepest question of all, how do we even compare different AIs when our very definitions of intelligence can be so different? And here's the thing. No single company or research lab is going to solve these problems alone. It's just too big. The only way forward is through a massive community effort. We're talking about crowdsourcing everything, the environments, the verifiers, the training recipes, with people from all over the world pitching in to move this incredible technology forward. So, as you can see, the cookbook for creating these verifiable agentic AIs is far from finished. The first few chapters are there, the foundation has been laid, but the most groundbreaking parts are still yet to be written, which really just leaves one final exciting question. Who's going to write that next chapter?